All right, so we are looking at geometric sequences, okay? So what is a geometric sequence? Well, the geometric sequence is a sequence in which each term after the first is found by multiplying the previous term by a non-zero constant r called the common ratio, okay? As with an arithmetic sequence, you can label the terms of a geometric sequence as a1, a2, a3, and so on. a1 does not equal 0, okay? So that's important. If a1 is equal to 0, then our term cannot be geometric. The nth term is a to the n, and the previous term, a to the n minus 1, and the previous term is a to the n minus 1. So a to the n equals r times a to the n minus 1. Thus, r equals a to the n divided by a to the n minus 1. That is, the common ratio can be found by dividing any term by its previous term, okay? So what is the missing term in the geometric sequence? Okay, well, how do we find the common ratio? Okay, we divide a term by its previous term. Okay, so here, 8 over 20, or sorry, 20 over 8, a term divided by the previous term. 20 divided by 8, we get 2.5. 50 divided by 20, we get 2.5. 125 divided by 50, we get 2.5. So our common ratio here is 2.5. So this is very similar to what we were doing when we were looking at our exponential behavior in a list of data, okay? So a geometric sequence is kind of like an exponential sequence, right? Where each term is multiplied by the common ratio, okay? So then to find the missing term, we multiply the last given term by our common ratio. The answer is D. So what is the missing term in this geometric sequence, okay? So we take term, pause the video, work out this question for yourself. When you're done working it out, come back to the video, okay? So here, we have all paused the video, worked it out, and now we are back. So question number 1, okay? So we take a term, and we divide it by the previous term. So we have 60 divided by negative 120. That gives us, well, we know it's going to be negative, whatever it is. 6 divided by 12 is 1/2, so 0.5. Now we're going to check, right? We don't just do 1 and then move on. We check to make sure that this pattern holds. Negative 30 divided by 60. Well, it's going to be negative because it's a negative divided by a positive, so we have negative. 30 divided by 60 is 0.5. And then, once again, just checking. 15 divided by negative 30 gives us negative. 15 divided by 30 is 0.5. So our common ratio is negative 0.5. So r equals negative 0.5. Okay, so now we take this, we multiply 15 times our common ratio. So we need our missing term. 15 times negative 0.5 equals, well, first of all, the answer is going to be negative, whatever it is. And then half of 15 is 7.5. So our missing term is F. You say F would be our answer. Okay, it's negative 7.5. That's the next term in our geometric sequence. Okay. Now, so our key concept here, the nth term, an, of a geometric sequence with the first term a1 and the common ratio r is given by the following formula where n is any positive integer, okay? The first term times our ratio to n minus 1, okay? So notice this is very, very similar to our equation for exponential growth, right? Our exponential growth is y equals c times 1 plus r to the, not to the n, to the t. Okay, but here our starting value, right, our c, and then our r is going to be just a common ratio, right? It's not 1 plus r, it's just a common ratio here. And then n minus 1, that's going to be our t value, right? So it's very similar to our exponential growth and exponential decay that we've been working with, okay? All right, find the term given, the first term, and the ratio. So we want to find the eighth term of the geometric sequence for which a1 is -3 and the common ratio is -2, right? So we give you, oh, sorry about that. It was a call from my wife. Anyway, okay, where were we? Find the term, find a term given the first term and the ratio. So we're given, find the eighth term of the geometric sequence for which a1 is equal to -3 and the common ratio r is equal to -2. So we're given our first term, we're given our common ratio. We plug that into our general formula, okay? A to the 8, we get 384, okay? Now we have this one, check your progress. Go ahead and pause the video, work this one out, and then once you're done with that, you can come back and check your work. I'm going to do this one right now. Let's see, adjust the camera slightly over. Let's see both at the same time. There you go. Okay. All right, there you go. I should have done that before I was recording. Anyway, we're doing this in real time. So let's see, check our understanding number 2. Find the sixth term. So our n is equal to 6. For a geometric sequence for which a1 is equal to -1/9. So a1 equals -1/9. And now we need our common ratio r, which is 3. So our basic formula, an equals a1 times r to the n minus 1. Plug in values as we have them. So we're looking for a6 equals a1, which is -1/9, times r, which is 3, to the 6 minus 1, which is 5. All right, so then we are going to plug this into a calculator, well, at least, let's see, 3 to the 5th power is 243, so that's -1/9 times 243. And then 243 divided by 9 gives us 27. So this is negative. Actually, I don't know. Well, yeah, I do. -27. All right, now I'm gonna throw this into my calculator again just to be sure. I wanted to do it on paper because it is a fraction. So -1/2 times 3 to the 5th. Oh, delete that, go back, there we go. -27, yep, we're good. All right. So there we go. All right, now write an equation for the nth term. Everyone's favorite thing. Given a thing, write an equation from it. So write an equation for the nth term of the geometric sequence, 3, 12, 48, 192. What do we need for an equation? Well, we need our first term, right, our an equals our first term times our common ratio and then n minus 1. The n minus 1 is going to stay as is, as we can see right here. Our first term is going to get plugged in, okay? And how do we find our common ratio? We just divide, right? We find our common ratio, and then we plug it into our formula, okay? So check your understanding, or check your progress 3. Let's go ahead and pause the video, do that one on your own, then come back when you're done. We'll go over it together. So I'm going to do this one now. So 3. So we need to check or find our common ratio. We need -3/18 equals, yeah, because it's take a term divided by the previous term. Let's see. Well, it's going to be negative. This reduces to 18 divided by 3, I believe, is 6. Yeah, 1/6. All right. And then we take 1/2, divide that by -3. Well, first our answer is going to be negative, and then 1/2 times, so 1/2 divided by 3 is actually 1/2 times 1/3, so that's also going to be 1/6. All right. And then -1/12 divided by 1/2 equals Well, first our answer is going to be negative, and then 1/2 times 2 over 1 is 1 over 6. All right, so our common ratio, R, is negative 1 over 6. All right. Find the nth term, so we need our formula, that's right. Our A1 is 18, so our AN equals 18 times negative 1/6 to the n minus 1. All right? That is how we find, and we put parentheses around it so that we remember that we are keeping the negative. The negative is also part of that common ratio, which can change our answer. All right, so there's our check your progress 3. All right. So find a term given one term and the ratio. Example number 4. Okay. All right, find the interim of the geometry for which A4 is 108 and R is 3. So we're given any one term and we're also given the common ratio. We know our formula, okay, our general formula. So we plug values into our general formula and then we just solve, right? Because we know the term we're given. So we can just solve for our common ratio, or not our common ratio, our first term, okay? So find the 8th term of the geometric sequence. Oh, wait a minute, what is this? Oh, so we were given the 4th term, and we had to find the first term. Then we have to find our 10th term. So we're going to do that here. Find the 8th term of the geometric sequence for which A3 is equal to 16 and R is equal to 4. Go ahead and pause the video and do this one on your own, and then come back and check. So number 4. All right, we've all paused. We're coming back. Find the 8th term. So we are looking for A8. I'm going to go ahead and just write this stuff down as we go. For which geometric sequence, so A3 is equal to 16. The common ratio R is equal to 4. Oh, okay. So now we need our AN equals A1 times R to the n minus 1. I'm going to write my general formula down just to help me keep track of everything. I'm going to plug in everything I am given. So A3, which is 16, equals A1, which we don't know, times our common ratio 4 to the n, which is 3, minus 1. All right, so this is 16 equals A1 times 4, 3 minus 1 is 2, so this is 4 squared. All right, so 16 equals, not 8, A1 times 4 squared is 16. Divide everything by 16, and we get 1 equals A1. All right, now we need to go back. First, let's write our A1 here. That's 1, okay. Now we're going to go back and recreate our general equation. AN equals A1, which is 1, times R, which is 4, to the n minus 1. And then we are looking for the 8th term, so A, not just 8, A to the 8. I did that twice, my goodness. A to the 8 equals 1 times 4 to the 8 minus 1. 4, let's see, we can just plug this straight into a calculator. All right, 4 to the 8 minus 1. We get 16384. So 1 times, it's going to be just 4 to the 8 minus 1, which is 7. All right. If you're the kind of person like I am, you're going to go ahead and actually carry out the 8 minus 1 equals 7 and then plug it back in. But it's still minus or times 1, right? So a to the n equals 16384. So 16384. We can go ahead and throw a comma in there. All right. So that is how we find any term in our geometric sequence given any one term and our common ratio. All right. Now, find geometric means. Okay, remember, arithmetic means are in an arithmetic sequence. You're given some values and you have to find some missing values. We're going to do the exact same process with our geometric means. Okay, so we're told A1 is this, A5 is this. Okay, okay, what do we do? We plugged in a common formula or general formula, then we plugged in what we knew, A5, which we're given, and then we're plugged in our A1, which we're given, and then R plugged in our N value, we get our fourth, okay? And then we have to take the fourth root of each side to find our common ratio. Once we have our common ratio, that allows us to multiply in and find our geometric means. Okay? Oh, and then it says the geometric means are 9, 36, 144, or negative 936 and negative 144. So where did this come from? Well, because when you take the fourth root of something, you have a positive and negative value, right? And that's the same. If you take a square root, you have a positive or negative value. If we are taking a cube root or a fifth root, right? If we're taking an odd root, then our values are not going to be, sorry, I started reading this question and distracted myself. Our values are not going to be alternating like that if we have an odd root, because it's going to be it's going to tell us the sign of our common ratio. All right. So find the two geometric means between 4 and 13.5. So let's write this down. Go ahead and we have 4, and then we have our first, comma, second, comma, 13.5. Go ahead and pause the video, work this out on your own, and then come back to it. All right. So here, this is A1, 2, 3, A4. All right. So we have AN equals A1 times our common ratio to the n minus 1. Okay. So A1 is 4. We're going to plug that in. Our R value we don't know, but we do know our N value, which is 4 minus 1. And we know it's equal to 13.5. Okay. So we have 13.5 equals 4R cubed. Okay, we're going to divide everything by 4. 13.5 divided by 4. We get 3.375 equals R cubed. Okay, now we need to take the cube root of this. So how do we take a cube root on our calculators? This is something we've not done before, okay? But you can do this for every single root. We type in 3.375. Take it to the power of 1 divided by 3. This is the cube root. Now this is using the exponent function to find our cube root. There is a way to actually find cube roots on the calculators, but I find this just as easily. It works just as easily. Okay, so that means 1.5 is equal to R. Now, do we need to do the plus or minus? No, and here's why. Because 1.5 times 1.5 times 1.5 gives us 3.3, right? We'll just type it in. Let's just demonstrate this through arithmetic. We get our value, negative 1.5 times negative 1.5 times negative 1.5 gives us negative 3.375. So because this was positive and we had an odd root, we know whether our common ratio is positive or negative. Okay? So now, find the two geometric means between 4 and 13.5. So we're going to take 1.5, that's our common ratio, and we're just going to multiply 4 times 1.5. Well, with 4 times 1 is 4, times 0.5 is 2, so should be 6. Okay. 6 times 1.5, well, 6 times 1 is 6. 6 times 0.5 is 3. So it should be 9. And I'm checking on my calculator, right? I'm not just doing the arithmetic in my head and then moving on. I'm checking. I could have just plugged these into my calculator the first time instead of trying to do it in my head. Either one would be fine. So that's the answer for check your progress 5. Okay, now we have arrived at the check your understanding in the packet. Okay, it's 1 through 13. All right, so go ahead and you can work on this, work through this. If you have questions about this, ask them at the start of class tomorrow, and we will go over it. Then we will get to the actual homework assignment for this. If you were absent the day that I passed this out, I did send the PDF home through Parent Square, so you can check that. So there you go, 1 through 13 for the check your understanding. You can do that as like a check for yourself, and then I am going to show you the answer key for the check your understanding first thing in class tomorrow.